Hello, welcome to m253 Calculus 3 Cañada College. My name is Lapuz. In this video, we will take a quick dive into section 6.1, vector fields. So what are vector fields? We can take a look at a couple of applications in vector fields. So we could take a look at the gravitational force between two objects in space, and the force that draws in to these planets or these moving objects would be gravity, and they can be depicted as vectors going inward towards the planet. And you can see the relationship between the Earth and the Moon, for example, and how the vectors might work into that. Another quick example is that if we take a look at a three-dimensional version of a vector field, we could take a look at a hurricane, tornado, and how the wind blows around. As the speeds of these winds get larger, the vectors get larger, and then they point in the direction that the wind is blowing. So here are a couple of examples of vector fields. So how are we going to study the vector fields? We could take a look at vector fields as an input-output relationship. One example of an input-output relationship would be if we have the vector field say x over 2 and x over 2 as x over 2, y over 2 as their input and output, and we can make a table out of that. So the input can be points, and then the output would be depicted as vectors. Now we're going to draw these vectors at the points, and so that would give some sort of special meaning to the outputs. In this particular case, we have negative x over 2 and negative y over 2 as our vector field. And for each of these points, there'll be a vector going towards the origin. Another common example, first example of a vector field is the vector field y comma negative x. And so again, making a table of inputs and outputs, and for each point will be assigned a vector, and we'll draw the vector starting at that point. And then in this case, we're going to have a vector field that kind of looks like it's circulating around the origin. So here are a couple of examples of vector fields and how we're going to sketch them. We're going to probably sketch a few by hand, but we're going to rely mainly on technology to be able to draw out these vector fields. One type of special vector field is called a conservative vector field. A conservative vector field is there's a relationship between vector fields and the gradients that we studied before. If you remember the gradient is an output of a derivative of a function of multivariable, function of two or three variables, and you put the derivative in each of the slots of the vector. And so basically the gradient is a vector output. Now that can be represented as a vector field, and that particular vector field is a special type of field called a gradient field. It's also called the conservative field. And so one geometric aspect of a gradient field is that if you were to draw those level curves, we know that the gradient's perpendicular to the level curves, so the vector field will be passing through those level curves in a perpendicular way. So we'll study these conservative vector fields, and they'll play an important part in one of the first theorems that we're going to study. All right, so that is our introduction to vector fields. Have fun.